Good morning, everyone. Today, we're going to explore a critical juncture in human history navigating the precipice, which involves understanding global risks and cosmic horizons. This presentation is a synthesis of cutting-edge global catastrophic risk research and the exciting developments on the 2026 space frontier. We'll be looking at two key concepts, the shield and the spear. The shield represents how we are intellectually arming ourselves to protect humanity from extinction, drawing insights from the 2025 Bibliometric Review of Global Catastrophic Risk. Concurrently, the spear illustrates how we are physically thrusting outward to expand our frontiers, inspired by discussions on the Reddit r/Space 2026 exploration. Let's dive into our executive summary, outlining the state of the future for 2025-2026. On the shield side, representing awareness, global catastrophic risk, or GCR, research has seen an explosive surge, from about 10 documents per year in 2010 to over 150 by 2023. We've identified 10 distinct clusters of existential threats, yet the field remains fragmented and demographically skewed. On the spear side, signifying reach, 2026 marks a pivotal shift in human capability. We're seeing the return of crewed missions to the Moon with Artemis 2 and the maturation of commercial heavy-lift vehicles like Starship and New Glenn. The synthesis of these two trends is crucial. We stand at a pivotal moment. Successfully navigating the precipice requires integrating these worlds. Understanding our fragility is a prerequisite for successful expansion into the cosmos. Now, let's map the danger by looking at the 10 distinct clusters of global catastrophic risk. These include foundational concepts, artificial intelligence, climate change, governance, pandemics, transhumanism, global resilience and food security, risk management, reasoning and risk, and emerging biotechnologies and futures. The key insight here is that the field has profoundly evolved. It's no longer just about nuclear anxiety, it's a complex web of interconnected mega-crises that demand our attention and understanding. Among these clusters, artificial intelligence and climate change emerge as the dominant threats. Artificial intelligence is the dominant cluster in terms of research focus, with a strong emphasis on alignment, power-seeking behavior, and the ethics of digital minds. Researchers distinguish between narrow AI, which is task-specific, and mature AI, which represents vastly superhuman intelligence. The primary risk mechanism here is the AI arms race, where the rapid acceleration of capabilities outpaces our ability to implement safety controls. Climate change, on the other hand, acts as the connective tissue for many other risks. It functions as a threat multiplier, linking governance failures directly to potential societal collapse. The focus has shifted from simple warming to critical concepts like tipping points, feedback loops, and geoengineering risks, such as termination shock. It's important to note that GCR literature primarily concentrates on anthropogenic, or human-made, risks over natural ones. To effectively navigate these risks, we first need clear definitions. Global catastrophic risk, or GCR, refers to events that cause the death of a significant fraction of humans, or a significant global loss of well-being, such as greater than a 10% population loss. Existential risk, or is even more severe, encompassing human extinction or the permanent curtailment of humanity's potential, for instance, through a permanent totalitarian state. So, why do we often fail to act on these critical issues? It's largely due to what we call the tragedy of the uncommons. We succumb to the unavailability heuristic, meaning we don't fear what we haven't historically experienced. This is compounded by mass numbing, where an enormous loss of lives is paradoxically less moving than the personal detailing of a single death. Despite the increasing research, our shield has significant blind spots, particularly in demographics and diversity. As this chart illustrates, approximately 75% of GCR authors are male across all clusters. Even more starkly, among the top 10 most prolific authors, 0% are female. Geographically, research is heavily concentrated in the US and UK, specifically institutions like Oxford, Cambridge, and the Bay Area. The implication of this lack of diversity is critical. It creates tunnel vision in risk assessment. We miss crucial perspectives on vulnerabilities from the global south and diverse communities, which often skews our solutions towards techno-utopian fixes rather than comprehensive, inclusive approaches. Let's shift our focus to resilience, moving from preventing risks to surviving them. In terms of food security, we consider scenarios like abrupt sunlight reduction, caused by events such as nuclear winter or massive volcanic eruptions. The solution lies in resilient foods, which involves repurposing industrial facilities to produce microbial protein and converting biomass and leaves into edible food. On the transhumanism front, the scenario addresses human cognitive limitations that prevent effective risk mitigation. The proposed solution is moral enhancement, modifying human biology or psychology to make us better, more cooperative actors. Interestingly, there's a clear link here. The desire to enhance ourselves for survival naturally leads to the desire to expand into space, seeking new frontiers and ensuring humanity's long-term future. Now, let's turn to the Spear and the exciting prospect of 2026, marking the Moon's return. In February 2026, we anticipate Artemis 2, the first crewed lunar flyby in over 50 years. Its objective is to test life support systems on a free return trajectory, crucially, with no landing planned for this mission. Public sentiment regarding this mission, as echoed in online discussions, is quite varied. We hear the skeptic, who views it as just a flyby and a waste of taxpayer money. The optimist, however, sees it as a necessary stepping stone, enabling scientific endeavors Apollo couldn't have dreamed of. Then there's the realist, acknowledging that stringent safety standards for 2026 mean zero risk permitted, reflecting the cautious approach of modern space exploration. The commercial velocity in space is accelerating dramatically, and our 2026 launch manifest highlights this. This timeline shows several groundbreaking events. We anticipate SpaceX's Starship full stack, including the Super Heavy booster, making its booster reuse attempt. There are also orbital refueling tests, upper stage catch attempts, the maiden launch of the Blue Moon lander, and the first private space station. A robotic lunar landing is also on the horizon. As one Reddit user aptly put it, Falcon 9 will be completely obsolete. Starship will have it beat handily in total payload. This underscores the transformative impact commercial heavy lift vehicles are expected to have on space exploration. Before humans expand into new territories, robots map the way, serving as our science scouts. In 2026, we're looking forward to key robotic missions such as Bepi Colombo's arrival, JAXA MMX's Phobos landing, and the James Webb Space Telescope and Plato searching for biosignatures. The connection to GCR here is profound. Understanding exoplanet habitability helps us define the Great Filter, the probability of intelligent life extinguishing itself before reaching interstellar capabilities. Of course, public perception is always a factor. As one Reddit user humorously observed, "I suspect the biggest space story of 2026 will be another nonsense conspiracy theory about aliens." Despite these monumental advancements, we face a significant public perception gap. There's recurring distrust of private actors, encapsulated by sentiments like, just using tax funds to help billionaires get their space thrills. We also contend with the safety paradox, where the public expects zero failure. This leads to predictions of fatalities, as seen with one Reddit user. And then there's the apathy factor, where the total lack of coverage for missions like Artemis is baffling to many. The stark reality is that just as the public is numb to existential risks, they're becoming numb to space milestones, unless those milestones involve disaster. This gap between technological reality and public sentiment is a critical challenge. Bringing it all together, we need a strong synthesis for managing risk on the frontier where GCR clusters intersect with space operations. Three key areas emerge. First, planetary protection, which involves preventing backward contamination, such as pathogens from Mars or the Moon, tying directly into the pandemic's GCR cluster. Second, great power conflict, as space becomes a flashpoint for US and China's lunar ambitions, a clear link to the governance cluster. And third, technological wildcards, exemplified by AI systems managing life support without human oversight, which falls squarely into the AI cluster. This leads us to the zero-risk paradox. While extreme safety standards slow progress, a hasty approach significantly increases the probability of catastrophe. Finding the right balance is crucial. To build a robust future, we have clear recommendations, divided into strengthening the shield and sharpening the spear. To strengthen the shield, we must first democratize GCR research by breaking the gender and geographic monopoly and actively inviting perspectives from the Global South. Second, we need to consolidate knowledge by creating diamond open access journals to aggregate siloed information. Third, we must connect, bridging the gap between technical AI research and global policy governance. To sharpen the spear, our first recommendation is to ensure continuity by insulating Artemis timelines from political volatility. Second, we need to balance strict public oversight, through entities like NASA, with private ambition from companies like SpaceX and Blue Origin. And finally, we must integrate GCR frameworks into long-term space settlement planning, proactively addressing risks as we expand. In conclusion, 2026 is far more than just another year, it's a critical testbed for humanity. It's a test for our technology. Can we catch a rocket, literally and figuratively? More importantly, it's a test for our wisdom. Can we effectively govern our own expansion into the cosmos? We must evolve from merely observing risks to actively governing them. We are, simultaneously, managing the precipice of global catastrophic risks while diligently building the bridge to the stars. Thank you.